So the third, threat model we are going to look at is a situation where the client itself is malicious. And when we were talking about when we were discussing the unit on software vulnerabilities, by and large, we were considering this threat model where there was a remote client that was trying to access the some server, and they were trying to exploit vulnerabilities in that server. So the server is benign, the client is malicious. Okay, so the network and so on are fine. We don't there is nothing malicious in the network. So the attacker is trying to exploit vulnerabilities on the server side, and they can exploit that to steal sensitive data from the server, to gain access to the server, and perhaps install malware or do anything else, manipulate server-side programs, some of which may connect to some backend services, exploiting them. Those are some of the possible motives. So OWASP is an organization which identifies some of the common vulnerabilities in web applications. We have mentioned this organization before in the software vulnerabilities unit, and they identify like top 10 as compared to another list that we have talked about, which is the common weakness enumeration top 25. So let's look at some of the examples here. The categorization here is a little bit overlapping. So for instance, we would consider some of the cross-site scripting attacks to be instances of injection, but they prefer to break them out as separate categories here. So so the injection category is one that we have discussed extensively. We talked about binary code injection, we have talked about SQL injection, we have talked about command injection, and so on. And in the case of web applications, you can also do header injection, cookie injection, and so on. And the reason why these are fairly easy and similar to other types of injections is because once again, it goes back to how these web applications are written. Very often you have so you have a server-side application that is producing HTML pages, and in addition, it is the same application that typically also produces HTTP headers. And so if whatever technique is being used to inject into the HTML page can also be used to inject into the HTTP header. So in particular, if you use a templating system and it uses some server-side variable and it's going to substitute that in the output, then to the extent that the server is using such variables for generating HTTP headers, then the attacker can inject HTTP headers in that case. And then again, it's very similar to how scripts are injected in the case of cross-site scripting. And the same way, cookies are things that that are injected on the they are things that can be included as part of the header, and therefore, once again, they are subject to injection. So all of these injection attacks can be done by a malicious client. And when we have already discussed many of these injection type attacks, and we have also discussed techniques for defending against them. So when we look at web applications in particular, one of the things to keep in mind is that we have to be mindful of the trust boundaries, because in the typical, say, buffer overflow type of situation, we are very aware that the client is malicious and we cannot trust the client at all. Whereas in a web application situation, sometimes we don't see this as clearly, because we tend to think, hey, the code running on the client side is also some code that the server sent to the client side. And that's partially true, but it's partially not true, because the JavaScript that runs on the page is certainly coming from the server side, but the browser itself is under the control of the user. So therefore, the browser, by controlling the browser, the user can do arbitrary things. And therefore, you cannot, for instance, rely on client-side scripts, JavaScript doing sanitization of data, because those scripts are under the control of the browser, which is under the control of the user. And therefore, a malicious browser can simply modify the sanitization or completely eliminate it. And therefore, these types of checks, security checks, have to be done almost entirely on the server side, and you can't rely on the client side to do those checks. So in summary, if you are considering that the user is the attacker, then you better make sure that all the security checks that you want to perform are done on the server side, and the only checks that are done on the client side are the ones that improve usability or functionality, but have nothing to do with security. So that's so again, the OWASP 10 has many different vulnerabilities, some of which we have talked about, like XSS and CSRF and so on. But there are also some generic categories like logic vulnerabilities, which are difficult to pin down. They can be highly variable, and we have seen some examples before, and there are a few more examples here. I'm not going to look at them and discuss them individually, but I would like you to actually read these slides and understand the examples, because in the exams and so on, we may have examples of vulnerable programs, and those vulnerabilities may very well be of the kind that are described here, right? So because seeing these examples, you can kind of understand, okay, how these vulnerabilities are introduced while designing these web applications, and also when you see those vulnerabilities in the exam, you might be able to more easily recognize them if you review these slides carefully. So we are coming to the end of this unit. So let me very quickly summarize some of the vulnerabilities in these applications and the whole web environment that leads to these types of attacks. One of the biggest issues is that you may end up trusting embedded content, like A.com embeds a script from B.com. Now, if this script from B.com happens to be malicious, then A.com is completely compromised. The second class of problems is related to the fact that SOP doesn't restrict outgoing network requests. This enables things like cross-site request forgery and clickjacking and so on. Okay, so there are because of these unauthorized outgoing network requests, web applications are to be designed carefully to make sure that any requests that are coming into the web application is in fact a legitimate and an authorized request. A third class of problems is that while you allow, by visiting a site, you allow arbitrary computation to be performed by that site by sending a script that performs whatever the attacker wants. So, for instance, they can do Bitcoin mining, or they can do side channel attacks. They can carry out, some types of attacks where, the script running on the browser is somehow able to hook into the vulnerabilities in the web browser binary code, and using that, it can launch a special type of ROP attack. So again, there are many things that can be done simply because you have untrusted code running on your browser, and therefore this untrusted code could be arbitrarily malicious, and therefore it can do many bad things. So and then you have weaknesses in lower layers. So in particular in the network, this is not necessarily unique to web applications, but is present for any service that operates over the network. But there are a few things that are particular, such as SSL stripping, which are very effective for web applications. So we talk about them especially. And then the last thing that we discussed, you have to be mindful of the trust boundaries. Make sure that you trust only the things that you should trust. Okay. And finally, we talked about the logic vulnerabilities. Okay. So, so that brings us to the end of this unit. So that's, let's stop here.